recorded. And then thank you. So for today's class, I'll be facilitating this class on operators in Python. Let me confirm that my recording is working as expected. Okay. So can you, okay, yeah, let me share my screen. Can you see my screen? One more thing. Let me turn on my highlighter. All right. Once again, thank you all for joining early. How many are we now? We are just about 7 of us here, right? That's not bad. We can move on. So in the previous classes, we've had our sessions on the very beginning, right? Setting up your system to start programming with Python, the different environments you can code in, which we extensively discussed in the previous class. And then we also had a revision on that in the last class. That was the Sunday class, right? And then in last week's class, we discussed extensively on variables, right? Variables in Python. And it was a very detailed class, in my opinion, as we covered a lot that you need to know about creating and working effectively with variables in Python. And bet me, believe me when I say that variables are one of those lifesavers that you would really want to make your friend as far as you are programming or you are a programmer, right? So if you did not join that class, I seriously recommend that you check out the video on YouTube. It's already live. It was streamed live, so it has been live from the time it was it was live even as the class was ongoing, right? So and then I don't know how many of you were able to attempt the exercise that was shared in the WhatsApp group. Can anyone did any of you make an attempt to maybe try to figure it out? There was an exercise shared in the group, and it was to test our understanding of variables, what we discussed, what we covered in the last class. So I don't know if any of you gave it an attempt. Can someone confirm, please? Hello? Hello? Did anyone make any attempts? Okay, if you made an attempt, can you kindly unmute and then maybe share your experience? Is anyone speaking? I can't see any hand raised. Well, that shows that none of you attempted it, which is not a good sign, because actually the easiest way to learn is through practice. Hello, Teresa, are you speaking? Hello?
No, just saying.
All right. So as I was saying, it's not so cool, and that was our very first exercise, and it was intended to gauge your understanding of the concept. At least if you had made an attempt, it would be maybe you look at it and see if the message was passed as intended, or maybe based on performance, we could maybe revise or maybe do one or two things regarding what we covered in that class. But now that none of you gave it an attempt, it will be difficult for me to really say if you understood the concept or what was discussed in that class. So please, going forward, always ensure that you do the exercise before the next class, and it's for your own good actually. And I must also mention that as long as you've called it a need to learn any technology skill, especially programming, there's this quality of being able to do it by yourself. You don't have to wait for someone to come and motivate you all the time to code, to do one or two things, right? If you must grow, because even as experts, you would still definitely run into issues which would require you to spend sleepless nights trying to figure out. So you just need to develop that very tough skin, right? And I'm not really surprised that our number here is dropping, right? Today we are about, this is actually 9 of us. Yeah, it's showing 10. That's my screen and myself. That means there are 8 students in class out of over, there are about 700 and something individuals in our community in general, right? I must also maybe acknowledge the fact that we did not send email reminder for yesterday and today, but regardless, the number is so poor. Now, those of you that attended this, that are currently on in this class, right? It's for your own benefit, right? So you need to understand that if you must embark on this journey, you would count the cost ahead of time, so that you know what to anticipate. Yeah, people would start with excitement, but along the line, people will definitely drop. I'm not saying that that's the ideal case, right? But it's a normal thing. So you don't have to wait for external motivation. Instead, you'll be able to push yourself. If there are obstacles you encounter, right, bring it up in the next class or in the WhatsApp group. Yes, we'll be very, very glad to work it out with you, right? But as for coming to class, doing this, doing that, you have to be the one to, if you have defined the purpose, right, then definitely you will not have to wait for someone to come and tell you all this, unless you don't really value the skill. Maybe you are doing it just because it was called free. Yes, we made it free for a reason, but that doesn't mean that we do not know the words. It takes time and everything to put together a class like this, sacrifice on our own part, but we're not counting those. We just want you to come and learn. So please make the best of this opportunity. You can go on YouTube and see recorded classes, but you can't actually compare that with a live class that you can ask your questions. So I believe a message has been passed across to us. So thank you all for those of you that are here. So if you are able to work on the exercise even after this class, yeah, you should be free to share with us maybe what you came up with. You can send it directly to the admins or to the WhatsApp group. Let's just see your strength, and then we'll guide you further. So please confirm that you can still hear me and see my screen. Hello?
Yes, we can hear you.
All right, thank you very much. So as I said initially, today we are looking at operators and expressions. It's mostly going to be, okay, operators are the key things there, right? We'll now bring them together in terms of expressions, how would they apply, right? Like we tag it as some of the core programming constructs, right? And then in parentheses here we see applying, like in levels of learning, right? You start with understanding basic concepts, definitions, and everything. Then the higher level of learning comes when you can apply what you learned and all that. So today's class is not going to be only about theories, right? We're going to see a number of these things in action, right? So we're going to talk about operators and expressions. And then, as you can see here, there are a lot of them. We have arithmetic operators, we have comparison operators, we have assignment operators or operator, we have logical operator, we have identity operators, membership operators. Then we'll talk about operator precedence and then compound expressions, how they come together, right? Let me just move straight to the content. Okay, so what are operators in programming in general, right? Now you can see operators as let me use a very relatable example. In English language, for example, we have different parts of speech, right? Now in programming, right, we still have something similar to that, like the basic fundamental things that that enable us to create or to coin logics and perform mathematical operations, among other things, right? So operators basically allow us to perform different kinds of things in programming, right? For example, arithmetic operators allow us to perform arithmetic operations, right? So you can see them. We have the plus, we have the minus, we have the multiply, we have the divide, we have the divide, we have the modulus operator, we have the exponential operator, that is to the power of whatever, right? Then comparison, just like we know it in our math, for those that have a maybe foundational knowledge of mathematics, we have comparison. We have the greater than, we have the less than, we have the greater than or equal to, we have the less than or equal to, we have the not equal to, and then we have comparison. We have this one is like equivalence operator, right? This one you see double equal to, right? We have another one called assignment, right? Which is in mathematics we call it equal to sign, right? A is equal to B, but in programming, especially in Python, it's assignment operator, right? We have logical, which is the and, or, not, right? We have the identity, which is and is not. We have membership, in and not in. Then we'll also talk about the precedence, how they come together, like which one comes first and the rest. Then compound expressions. So now let's look at arithmetic operators, and the easiest way to understand this is you understand that Python is a calculator, right? Python is a calculator. What you see here now, for example, let me just create a cell here. Maybe if I type 2 plus 2 or 2 plus 3 and hit enter, I have 5, right? This is typically what you get with your calculator, right? Python is a programming language, which means it's just a means to instruct the computer to perform certain actions, right? And it's not just a basic calculator, it's a very advanced calculator, right? So arithmetic operators allow us to, they contain different kinds of functions or symbols that have been pre-programmed to perform certain actions. For example, in this cell I have the 2 to the left, the 3 to the right, right? And then this sign, which is plus, right? Now Python already understands, the Python interpreter understands that when you put 2 to the left, when you bring two different numbers and then use this sign, which is this plus sign between them, it tells it to sum up the two of them, the one to the left and the one to the right. If I change it to minus, right? If I change it to minus, it gives me -1, because 2 minus 3 is -1, right? So so it's easier to maybe just when you talk about arithmetic operators, just take it as it is, arithmetics, right? Addition, multiplication, division, and the rest. The operators allow us to perform such arithmetic operations. So as you can see here, we have print 7 plus 9, right, in parentheses, then it gives us 16, right? This print here is a function, right? But the main thing here is the 7 plus 9, right? The sign, the symbol in between is the operator, right? Then the ones to the left and the right are called the operands, right? What you are performing the operation on. So this 7 plus 9 gives me 16 because Python understands this operator plus, that it means bring this one and increment it, add 9 to what you have to the left here, and then the result gives us 16, right? So here now you notice that if I come here again and execute this line of code, this second line, it still gives me 16, right? Even though there's a white space in between. If I press 7 space plus then space 9, it still gives me 16 because Python ignores white spaces. Like white spaces, they help make code readable in some sense. Like it still understands everything enclosed within this parenthesis, right? Please, this might be confusing, but there are cases whereby white spaces matter a lot, right? Especially when you are applying some control flows and all those things, right? But in this case, whereby we have this function called print, right? And a function starts with mentioning the name of the function, then opening parentheses, then supplying it the arguments, what you want it to perform on. Like this 7 plus 9, then the second parenthesis. So as long as they are between this opening and closing parentheses, it will work, right? So this is just a little deviation actually, but that's just to mention that 7 plus space 7, then white space plus white space 9 still gives me the same thing as this one, right? Now, another operator we can look at is your subtraction, right? Like the minus sign. So, but so you can see if I change this to minus sign, that is a 20 minus 8, and I execute it, it gives me 12, right? And because I'm using Jupyter Notebook, right, I don't necessarily need to use that function called print because Jupyter Notebook is an interactive coding environment. So I can just simply say 20 minus 8 and it gives me the answer, right, the result. But if you're using some other programming, some other IDEs, right, that is integrated development environments, you might need to explicitly, if you want it to display, the result to display, you might need to explicitly call this print, as print whatever you want it to print, right? So that's what you should take note of. Now, 8 minus 20 gives me minus 12, right? In this case, we had 20 minus 8, but here 8 minus 20, meaning that it understands both the left hand, like it functions just like every other calculator. Every other calculator will tell you that 8 minus 20 will give you minus 12. So please confirm once again that you can hear me and see my screen before we go too far. Hello? Am I talking to myself?
No, you are not. I can hear you, sir.
We can see you.
hear you.
All right, thank you. So, and then just to mention, I don't think I have any of my colleagues in the background, so someone can volunteer. Shegun, please, if at any point I trip off, maybe you stop hearing me, can you kindly, okay, Richard is here. All right, Richard, thank you. You can see that.
Yeah.
So the other one now is the multiplication sign, right? Normally we are used to something like maybe 2 times 2, the one that looks like x, 2 times 2, or 2 times 2, right? If I do it in Python, it will give me syntax error because it does not understand this x sign, right? So if you want to do multiplication, what you use is this asterisk, right? You would find asterisk on your keyboard, just press it, right? The one that looks like star, that is what you use to perform multiplication, right? So you can use that to multiply, right? So 20 times 8 gives me 160. 8 times 20 still gives me 160, right? So this is just like just play around with the values, see what it gives you, whatever. Now if you want to divide, this is the sign, this is the operator you use, right? Is this forward stroke, right? Isn't this forward stroke? Yeah. forward stroke is what you use for subtraction. So let's say I want to do 20 divided by 5, which should give me 4, right? Should give me 4, right? So you can verify everything here. 5 divided by 20 gives me 0.25. Minus 20 divided by 4 should give me minus 5, as you can see here. Then minus 18 divided by minus 16 should minus 6 rather should give me 3, right? 3.0, which is a float. Now when you use that same symbol, but this time around, if you use it in 2 places, right, you can use it. That means you are raising it to the power of. Let me demonstrate that. If I say 2 asterisk 2, it gives me 2 times 2, which is 4. But when I now change it to 2 double asterisk 2, okay, well, it will still give me 4 because 2 raised to the power 2 is still 4. Okay, let me use another number. 2 asterisk 3 gives me 6. But when I use 2 double asterisk 3, it gives me what? 2 to the power of 3, which is 8. So when you use this asterisk sign together in two of them together in between the operands, right, you end up getting the left hand side raised to the power of what is at the right hand side, right? That is what that's how you do it in Python, right? Okay, I'm just trying to demonstrate something. Now the next thing we look at here, this is just like examples, right? Now the next thing we look at here is this percentage sign, right? The one you see here, I could have maybe 100%. What the sign, the symbol for percentage, right? It's also an operator in Python. But what it does for you in Python is not like you would typically have it in your normal calculator. Instead, it is called a remainder operator, right? In the sense that if I want to see what remains after I had divided the number to the left by the one to the right, I will use this operator, right? So in this case, let's say 300. Usually 300 divided by 10 should give me 30, right? 30 remainder 0, right? So but then if I want to know what is going to remain when I have performed the division, right, that is 300 minus 10 will give me 0 because there's nothing remaining. But if I say, for example, 5 divided by 2 should give me 2 remainder 1, right? So if I now do 5, so we now say that what is left is what remains, right? After I had divided, right? After I had divided, what remains after I had divided? Now, there's another one which was not actually included here, which is when you now use this double. When you now use this double. Hello.
Can I? Hello.
Yes, I can. You can speak.
Yeah, I don't know if it is from my side or from all of everyone's point of view, but I think your screen is not moving though. I don't know. I guys, you can confirm that maybe it's from my side so that I can just refresh, or if it is not from my side, then
All right.
yeah, like your screen
What,
is not moving, but I
what
think
can you see
I
right
can
now?
hear you. I can see the 4.0 output. I don't know if it is. Please, if it is from my side, you can confirm so that I just refresh my
All right. So
browser.
Teresa, please, can you
Everyone.
confirm? What can you see on my screen?
I can see your screen. Your screen is moving.
What are you seeing currently?
Your profile picture, I think. Yeah.
Okay. So Richard, it seems like it's from your end.
Okay, then let me refresh. Yeah. Thank you.
All right, thank you. So the second operator that looks similar to the first one we demonstrated, I told you just now that when I say 5% 2 gives me what remains after I had divided 5 by 2, right? So 2 will go in 2 places into 5, and then leaving 1 as a remainder, right? So this operator helps you do that, right? You will definitely need this when you want to perform certain operations. Maybe you want to know, maybe you are converting time from hour to days, or from days to hours to seconds, whatever you want to do. You would want to do whatever is left, right? You want to know what remains after your operations and every other thing, right? But the second one that complements it is this one, which for example, which is a double division, right? So if I say 5 double division 2, what happens is that it returns for me 2. This one shows you in how many places can 2 go into 5, right? 2 can go into 5 in 2 places, right? So if I change this to maybe 10, tells me 5, right? So 2 can go into 5 places in 10, right? So this one tells me, this operator tells me the number of times a number can go into the other one, right? Like what is the value you will obtain after dividing a particular number, the one to the left by the one to the right, right? In how many places, how many times can this number go into the other one, right? So I think I will have to include it here, maybe, so that I will not forget it. I'll have to update this note later on. Okay, yeah. So I hope the point is clear, right, in terms of what each one does, right? So you can now see, let's look at remember, we have this one which shows you what remains. That is the remainder, right? So let's say 20 divided by 6 would give you 3 remainder 2, right? So it means we're expecting to see 2 here when we divide. But in this case, if I say 10 divided by 3, right, it will give me 3 remainder 1. So if I run this code, let me just comment out these ones. The first one should give me 2 as expected, because 26 can go into 20 in 3 places, and then 2 will remain, right? So let me just uncomment the rest so that we'll see. For this last one, 6 divided by 20 cannot go, right? As it told us when we were kids, that it cannot go, even though it can go, right? Instead, it returns for us 6, right? Why? Because 6 divided by 20 cannot give us any whole number, right? Cannot give us any whole number. Sorry. I hope my screen is recognized. Okay. Because 6 divided by 20 cannot give us any whole number, right? It will only have a remainder of 6, right? I hope you can still hear me. I got this notification. I don't know what it's all about. I hope you can still hear me and see my screen if I proceed. Hello?
Yes, I can.
All right. So now we've kind of seen the different operators. The ones we've been discussing is arithmetic operators, right? That's everything here, from the plus, minus, multiply, divide, modulus, exponential. That is to the power of this one, I think the remainder also. So an interesting thing here is that we can use all these things together. Like, what we are still learning is the ABC of programming in Python, right? And like I mentioned in the first class, in learning any language, right? In learning any language, you first need to understand the different letters of the alphabet, right? In English, for example, you need to know that there are 26 letters in the English alphabet, right? Now, it's by the time you've understood the alphabet, the letters of the alphabet, you know what makes up the letters of the alphabet, that you can now start talking about words, right? Forming words. From letters of the alphabet to words, right? And from words, you start putting words together to form sentences. And then when you start forming sentences very well, right? You are able to make correct sentence in a particular language. That's when you begin to form paragraphs. From paragraphs, you can begin to even talk about chapters to books, right? So we've only seen how to use what the different operators are, right? And what they do in Python. Right now, this line now is like, let's see how we can put them together, right? So in this first line, I have 1 plus 2 times 3, right? 1 plus 2 times 3. The answer is already there. I would have asked people, maybe someone can guess what the answer would be. Now, 1 plus 2 times 3, we have plus here. We have multiplication sign here, right? Now, how does Python know which one to perform first? Will it come and add 1 and 2, that gives us 3, then multiplies it by 3, that gives us 9? Or will it come and say 2 times 3, that gives us 6, then adds 1 to it, that gives us 7? I think you all saw the answer there. Maybe if you didn't see it, maybe you can just guess. What do you think the answer would be? Can anyone try? There's room for mistakes here. I just want you to feel free.
6.
You said 6.
I think I saw 7. So I guess it's following.
Yeah, that's already a spoiler, though. So, but can you
Sorry,
explain what
I
happened?
said 7.
Sorry?
I said it's 7.
Yeah, okay. So, why do you think it's 7? It should be 7. Why not 9?
Okay, it uses BODMAS, and you have to multiplication comes before addition.
All right, thank you very much. That was exactly it, the correct answer. The correct answer is that it uses BODMAS. For those who maybe don't have strong background in mathematics, we would also talk about that, right? It tells us that since we have plus and then we have multiplication, right? BODMAS is short form of in other countries they call it PEMDAS, right? So it's just let me see, BODMAS. That is the B representing that is a bracket or whatever. Brackets of. That means when you have expressions in parentheses, you start by simplifying the ones in the parentheses first before you now start expanding to what is outside. We have the division and multiplication have their own. Division and multiplication have equal precedence, right? So the two of them have equal precedence in some sense, right? Now we have the addition and the subtraction. So addition and subtraction come last, right? That's why in this case Python had to multiply this one and this one, 2 and 3, to give us 6 first before adding this 1 to it, even though this plus came before the multiplication, if you're looking at it from the way it was specified. So even if I take this to this side, right? Even if I take this one to this side, take this to this side, it should still give me the same answer. It doesn't matter. It follows its own rule, not how it was spelled out here. So it will do multiplication first, 2 times 3, then adds this one to it to give us 7. And then the same rule follows here. Okay, can someone tell us what the answer to So this one would now be 1 plus, okay, well, no need again, they are still the same thing. But that's how the precedence. Now this second one gave us, yes, okay, yeah, they were not exactly the same thing. This second one gave us 9 there. Why? Because we had these two, this one enclosed in parentheses, right? 1 plus 2, and I just illustrated before us now that in board mass you have to simplify what is inside the parentheses first, right? So it first addressed what is inside this parentheses, which is 1 plus 2, right? You can see that we have an inner parenthesis. The first parenthesis here, let's see how it works. Let me just remove everything first. You see that we have print, which is a function that is expecting something that needs to be printed, right? Now, inside of it, I still have another parenthesis that contains 1 plus 2, then joined using this multiplication sign to this 3, right? That gave me this expression, right? So now in Python, what will happen is that it would first simplify what is inside the parenthesis, which is this 1 plus 2 that gives me 3, right? Then, having gotten 3, that means this bracket, this parenthesis is off, right? What it now sees is now to replace this expression with what? With simply 3. So this is what it now sees. Then it now comes again and then sees that there's a multiplication sign between this one and this one, right? So it now does again 3 times 3 gives me 9, right? So that was what happened here. And let's look at this one. In this case, we have, I think this one is the same as the first one. The parenthesis doesn't have much impact here too. Or well, it still has. So it still started by simplifying what is inside the parenthesis. 2 times 3 gives us 6, right? So it sees 6 here. It replaces whatever is inside this parenthesis with 6. Then it now sees again 1 plus 6 gives us 7, right? So we have our answer. So the way you organize them can actually affect the final result you get, right? Now you can see that this first one, okay, let me just take this one up. You can see that this first one and the second one here are supposed to give us the same thing, but one is more elaborate, one is clearer, like one is more readable, right, than the other. Like if I want my expression to be more readable, maybe I have a very long equation that requires multiplication, addition, all those things. It's better, it will be more readable if I start making use of parentheses to enclose them, to group them the way I want. Otherwise, I can also make it easier for myself, and that is for my future self that will come to read that code, and for any other person I'm collaborating with, by instead of specifying the full, maybe something like you will still come and have divided by 65 minus 89 times 10 raised to the power 8 plus 150. You know, we have longer expressions like this, right? There are times whereby it is safer, maybe you split up these things in shorter form to make your code readable. Maybe I'm trying to calculate a particular value. This first one is a constant, right? So maybe I can simplify this using, maybe let me just show a more readable alternative. Maybe this one is a constant. Maybe you can call it C, which is what I know, equal to 1. Then the one in parentheses could be maybe this whole one could be something like x equal to this, right? Then this one here could be y. Then this one here could be z, right? Z equal to this. Now, to make that code very readable, what I will do now is that I would come here and then let me create another cell here. I will now say maybe result, or whatever the name of the variable is equal to I already know that what is supposed to be here is C, right? That is, it will now be C plus, right? What is inside there? The whole of this thing, I named it X, right? Then this side is I named it Y. That means plus X minus Y, right? Then this one is Z plus Z, right? So this is clearer than specifying everything in full like this, right? So let's see what it gives us. This one is giving us minus 9,460. Okay, I've not told you to print results, or maybe print result. So it's the both of them gave us the same thing, but this one here is more readable, right? Although it's longer, but it's more readable. Now you would find out that if you, for example, you are collaborating with someone on a project, right? Though you that wrote this code, you that wrote this here, you understand what you did here, but that other person might not really understand it. So it's always good to write a clearer code, and not just for the other person's sake. You might come back tomorrow, maybe you wrote this thing over the night, maybe you just had a spark of intuition and then you're able to come up with this, but maybe tomorrow you might come back from work with some, maybe I don't know, you're not just in that same mood you were when you wrote this first thing, right? And then you are coming and you'll be confused, like, what on earth is this? Like, you'll be confused, right? So it's better to write clearer code, just like we have seen here. And since we already know what variables are, right, at least this is where we'll start piecing one. This was one of those typical examples where variables can save the day for us, right? So that's it about the arithmetic operators, right? Now the other thing we have to look at here, right, is there are other operators we have in Python, right? We just covered the arithmetic. We still have assignment operators, we have comparison operators, we have logical, identity, membership, right? Now let's look at the assignment operator. What's an assignment operator? An assignment operator is simply used, it simply means our normal equal to, that is equality sign in mathematics. But please, it can be a bit tricky, but please, from today, just know that anytime you are coding in Python and you press this sign, which is equal to, it is not exactly the same as the equality sign you have in mathematics, right? This is called equality, this is called assignment operator, right? And what it does basically is it is used to assign a value to a variable, right? And now it's used to assign a value to a variable, meaning that a place somewhere in your computer memory, you are telling it, hold this value called 2, store it somewhere in memory. Now give that memory name called 2. Called length, right? The value stored saved in that memory is 2. Now you are not giving it the address to that particular place in memory. You are not giving it a name called length, right? Now to join this to this, that is to make this naming or name assignment work, right? You are going to use this operator called assignment operator. Now in this second case, we have width equal to 4, right? Meaning I have assigned this value of 4, which is stored somewhere in memory, to a name called width, right? So I've given this the address to that place in memory, width. I've given it a name, so that the next time whenever I call length or width, it returns for me the value that it holds, which is 4 or 2, depending on the current value, right? Now, one thing to know about assignment operators is that you can reassign. Okay, that was covered in variables, right? So I don't need to talk about that again, but just to mention, if you are not there, this length called assign the value of 2 can actually, you can as well come down somewhere again and change it to whatever value. Then the current value of length becomes the most recent that you assigned to it, right? Now that's just it about assignment operators. You just use it to store value to a variable mostly, right? Now the other one is the other ones we look at now is are comparison operators, and just as their names imply, they are used to compare two values or expressions in Python. They are used to compare two values or expressions in Python, and the important thing to note here is that they return a Boolean value which is either a true or a false, right? If, for example, I have okay, maybe before I go into that, let's say it returns a true or false depending on whether the comparison is correct. Now let's look at examples of comparison operators, right? I have this one called equal to, right? But you can also call it maybe equivalence, sort of, right? Now what it does is that it takes the value to the left. You are telling it, look at this value, the one to the left and the one to the right. Are they the same? Right? If they are true, if they are the same, it will tell you true. Like in this case now, 5 and 5 are the same thing, right? 5 and 5 are the same thing. They hold the same value, right? For example, even if maybe this 5 and 5, let me just create another say, maybe the first one is maybe width is equal to 5, then length, let me not rewrite this, let me call x is equal to 5, then y is equal to 5, right? I can ask Python x equal to 5, x equal to y, and it will tell me true, right? Because the value x is holding is the same as the value y is holding, right? Even if they are decimals, let's say even if they are, like this one, they are not the same data type. Like in this case now, this one is in float, a floating point value, which is like a number with decimal. If you have been attending the R class or our previous Python classes, we've covered data types, right? So, but as long as the values are the same, like this one is holding the same values, that is very, very the same as the second one you're comparing it with, it will return true for you, right? Now let's change this thing to, let's change this one to 6, x to be 6, y to be 5. Now it's false. Now you're now like, is the value of x the same as the value of y? It tells you false. Now you are going to use this a lot, whether you like it or not. It is very easy, very simple to understand. But we are most importantly going to use it a lot because it's going to come. In fact, everything we have covered so far are like the pieces. They are like the alphabets. They are like the letters of the alphabet I kept mentioning in programming, right? Now that you've understood, at least you have an idea of what this equal to sign does for you, right? It compares the left and the right and tells you if they are the same, it tells you true. If they are not, it tells you false, right? Now, in coding, right, when you start creating your coding logic, right, maybe you are asking somebody, maybe the actual password, something like maybe actual password. Maybe the actual password of that person is equal to, maybe is Sam 360, right? Now you have a place whereby you're asking the user to enter their password, right? So let's do something like let's just try it out. So let's say actual password equal to, I hate this, actual password equal to maybe Sam 360, right? Okay, now you've stored this thing in somewhere in memory. Now, you want the user to enter an input, right? You want him to enter an input, maybe to enter their password, right? Someone saying something.
But should you be having any questions, anything to talk about? You can let me know. I'm here though.
Hello. Seems you've not been hearing me. Hello. Hello.
Hello, we can hear you.
For how long have I been off?
I think it's a few minutes. Not a minute though, but like,
Okay.
yeah.
I'm surprised. Seems someone muted me because all of a sudden I saw myself muted. Please, I don't know. But sorry about that. So maybe can someone take me back a little? Let me know where.
I think you were at where you were where you had x equals to 6 and then y is equal to 5, and then we are comparing x to y.
Okay. All right. I think I've actually, okay, well, that's fine. That's here, right? And then it's returned for us false, right? Can you still hear me? And see my screen?
But your screen is not moving. I don't know if it's from my end.
All right.
Yeah, you are. I don't know if you are still sharing your screen, but I don't think it's moving.
Okay, I just reshared it now. Can you see it now? Has it come up?
Yeah, yeah.
Okay, thank you.
Yeah.
Thank you for that.
Yeah, it's up.
All right, thank you for that. Now, what I was trying to say is that this assignment operator only helps us to map a value stored somewhere in memory, give a name to a value stored somewhere in memory, so that instead of remembering the actual value, I will just simply remember the name. Now, as humans, it's easier for us to remember names than numbers, but for computers, it's the opposite, right? So we want to bridge that gap. We want to give the value we stored somewhere in memory. We want to give it a name so that it will remember it for us. Now, that is assignment, right? Now, assignment usually comes first when you talk about some of these operators, because it's when you have assigned a value that you now start comparing in a way. Like in this case now, I've assigned this x to be a value 6 and then y to be a value 5, right? Now, I now came here to, let's say, let me see, maybe compare. Maybe the first part here is going to be assign. So here now, this is like a comment. Like I have assigned values to these variables x and y, right? Now I want to compare. Remember, comparison operators are what we are discussing. They are used to compare values. So I now came here to ask it, is x the same as y? The value of x the same as the value of y? It tells me no. It tells me false, because x here is 6, y is 5. 5 and 6 are not the same. But if I change this to 5, it tells me yes, that's true, right? That's true. So what I was saying is that as long as you are coding in Python, you're going to definitely use all this, right? At least. So let's see how we can use this comparison operator in real world scenario. Maybe this equivalence operator, right? This one, or whatever. Right? Now, in this case, let's look at maybe you have created an application that requires a user to sign in, to enter their username and their password, right? And initially, when they created their account, they saved their username and password. They provided them, and you have saved them somewhere in a database, right? Maybe my username, maybe my name. Or let me use whose name should I use? Let's use Shagun, right? the name is Shegun, the actual username is Shegun, the actual password is Sam360, right? Or yeah, let's just keep it at that. Now the next time they want to log in, right, you would want them to provide the same credential, that is the username and the password, right, to confirm whether what they supplied is the same as what you have stored in memory. So let's see how we can accept inputs from user. Let's create an maybe a simple logic sign-in authentication that does that for us. Let's say you now say username, and I hope you also know that you can accept inputs, raw inputs from users. So now we can now say username equal to input, maybe username, right? Then let's say password. This is not intuitive because this is okay. I'm typing intuitive. Come on. Password. Let's see if this is going to work here. Now I'll tell it if username equals, that is the same as actual username, which is the one you already have, maybe which is the one already provided here, is actual username, and let me just close this, and password is equal to actual password hope you can still hear me. All right, then you would want Python to do something, maybe print something like successfully log in, right? Okay, now let's see how this works. Now this first line asks me for my username. Can you see it? I will now supply maybe Shegu. Okay, well, this is not the best place to run this kind of code. Okay, then this password, I now supply what? Sam360, right? So it tells me successfully logged in, right? So what happened here was that it compared the input. This username, I used this username to collect the username of this guy that wants to sign in, and then I used this second input to collect the password, right? And then compared the username to the actual username that the person saved, then the password compared to the actual password that the person saved. Then it happened that they matched, so I told him successfully logged in. Now let's rerun this and see. Maybe I provided the correct username, okay, or maybe it did not tell me successfully logged in because I did not provide the correct value. This is just a dummy app. So now let's say maybe L, if we've not done that is control flows and the rest. So what we are doing now may not really make sense. Or let's say else. Just keep things simple. S. Print. You have supplied an invalid detail. Whatever it may be, just pardon that. Okay, now let's rerun this. So in this case, I tell it, okay, let's say username is the actual username. Let me say I got the correct username, which is Shegun. Then password, I now missed. Maybe instead of Sam360, I now enter Sam350 or Sam330, right? So it tells me you have supplied an invalid detail, right? Now, what you need to take note of here is when I used this double equal to sign, right? I used it here, and then I also used it here, right? There are still some other operators we are going to look at, which I used here, which we've not covered. This one, which is a logical operator, right? And you could see that we also use parentheses to keep the code maybe logically more organized, right? So that's one of those examples where you can use this. You use this a lot, right? You use this a lot. So what happens here is that it looked at the username that the user supplied, which is Shegun, right? And then compared it, placed it by the left, compared it with the one that was saved in memory, and it happened that they matched. That's for this first case. Then it now looked at the second one, which is the password, which was supplied here as Sam30. Then compared it with the actual one that was already saved at the time I created the account, which is Sam360. It now happened that they did not match, right? Now it threw up this second line. Instead of executing this first line, which is successfully logged in, it came and executed this one, which is you have supplied an invalid detail, right? So, but this comparison operator allows us to do that, right? Hello? Can you still hear me and see my screen?
Yes,
okay, thank you very much. Now, the other comparison operator we're going to look at now, we've just covered the first one. The second one, okay, I did not follow them in order, but the second one should be greater than. The second one should have been not equal to, right? We'll still touch that, but let me follow what I already have here. So I have the greater than, right? Remember we already assigned values to width and length here, which is when we did the assignment. Width is 2, length is 4, right? So now let's look at it. This is normal greater than sign. That is the one that looks like this. This right angled symbol, right? That is greater than sign. Now it says length. Is length greater than width, right? It says false. Okay, now let's go back. Length here. Come on. Our length here is 2, and width is 4. So 2 obviously is not greater than 4. So it returned false for us. So that says that's another way to still buttress the fact that what the computer basically do is look at the one to the left, the one to the right, and check if they meet the criteria specified. Then it returns true or false depending on the case, right? Now less than sign just works like the greater than sign, just that it works in the other way around, being that length is less than width. We already established that our length is 2, width is 4. So definitely 2 is less than 4. So if I run this line, it returns true for me, right? Okay, now this other one, which should have been the second, is not equal to sign. It's not equal to. What makes it not equal to is because of this exclamation mark coming before this equality sign, right? So what this one does is that it's like a negation. It negates what this one does, like the opposite of what this one does, in a sense, right? So it says, is 2 not equal to? That is, if for example in this our case where we have length and width, length is not equal to width, what should it return? Of course 2 is not equal to 4. It returns true for us, right? So if I remove this and maybe I add another one, this will return false for me, right? But because I have negated it like this, like a negation of this other one, right? It returns true for me, right? Then we have another one which is a greater than or equal to. What that one does is it looks at the value to the left and then the value to the right. Then if the value to the left is greater than or equal to the one to the right, it returns true. Otherwise, it returns false, right? That means in this case, where we have length and width, right? It sees length and checks. Is length, it checks for two conditions here. It checks, is length greater than width? Then the answer is, the value is no, because length is not greater than width. Then it also checks again, is length equal to width? The answer is still no. That means it returns false for us. But had even it met the criteria of length is greater than width or length is equal to width, right? It will have returned true. Now look at it here. Length greater than or equal to width, right? Will return false for us because in our case, length is 2, right? And 2 is not equal to 4. Neither is 2 greater than 4, right? So it returns what? It tells us false, right? Now we have the other one, which is like the one complementing it, which is less than or equal to. Sorry, this is where, yeah, this is it. Less than or equal to. Now to do this, right? This symbol is gotten by simply, maybe you want to create a cell, right? Just see X. Then, if you want greater than or equal to, press down the Shift button if you're on Windows. Then press the right angled key. You see. Then press the equal to sign. Then the right hand sided one. So let's demonstrate that. 3 greater than or equal to 3. What should be the answer? Is 3 greater than or equal to 3?
I think it's false. Because from the length greater than or equals to width, though both of them are false, but the second one is saying length less than or equal to width, and it's saying true. That means it first consider the first operator before going to the second one.
Okay, thank you for that attempt. Any contrary opinion? Is there any person with
Yeah.
All right.
Yes, sir.
Can I write down?
Yes, you can.
The answer is true because the question is simply saying is 3 greater than or equal to 3. In other words, it needs to meet at least one of the conditions. There are two conditions. Either 3 is greater than 3 or 3 is equal to 3. In this case, 3 doesn't meet the condition of being greater than 3, but it meets the condition of being equal to 3. And because this operator needs the operation to meet at least one of the conditions, which in this case happens to be 3 being equal to 3, it will still give you a true value. So it's true.
All right. Yes, that is actually the correct answer. Thank you both for your attempts, right? So what happens here is that it checks for 2 different conditions. Remember that this one is already, remember that we already covered the greater than sign, right? Where it was standing alone, right? It's just like it checks the first. Okay, let me just break down what happened here. Let me run it to confirm that true. Yeah, as we already expected. Now in this case, it first checks for condition 1. For first condition is 3 greater than is 3 greater than 3, then it discovered that the answer is a no, right? 3 is not greater than 3, right? Now it comes again. That's for this one, right? Then it comes again and then checks for second condition. Checks for second condition. Is 3 equal to 3? Now the first person that answered, I did not take note of your name, but is 3 equal to 3? Hello? Are you still there? Hello?
Yes.
3 is equal to 3, right?
Yes.
That means no 3 is better than another 3. Alright, so the answer is yes. Now remember the name. That is for this one. Sorry. So what happened here is that it met the condition of this second one, whereby 3 is equal to 3, right? But it failed in this one. But what is required here is that if at least one of the conditions is met, it should return true, right? So the correct answer was now true for us. So thank you for that attempt.
Okay, I'm sorry. So it means that um, if it gives us false, it means that the two conditions does not apply. But once we have a true, it means that it's meeting one of the conditions.
Yes, that's what
Okay. I was
something.
thinking it follows the operator signs.
No, it doesn't. This is logical,
Okay.
right? This case is logical operators. So that's how it works. Greater than or equal to. You need to know how to pronounce this. Or when you hear or in logic, we are still going to cover them. Okay, yeah, that's the next thing we're going to talk about, rather. So I think that will make it clearer for us. Now we've already covered equivalent, which is length equivalent to width. No, right? Now logical operators come next, and there are two of them primarily, which is the and or, right? Now the third one is used for negation, right? Just for negation, but the two basic ones are the and or. So now that I'm still there, right? So what happens here is that what do they do? They are used to combine multiple conditional expressions, right? We've seen different conditional expressions. Okay, we've not really we've seen how we use the different operators, like the comparison operators and the rest. So logical operators are used to combine multiple expressions like that together to help us make meaning, right? So they help us form more complex conditions in our code by connecting two or more comparisons, right? So they return a value, a Boolean value, which is true or false, right? It evaluates. We will see them very shortly. So there are three of them. We have the and the condition. The and operator returns true if both expressions are true, right? And means that everything in the expression has to be correct. They have to be true before it returns true. So that means 5 is greater than 3. It will evaluate this one and discover that 5 is actually greater than 3, which is true. It will return true for this one. Then it will come again and evaluate 10 greater than 2, which is also true, right? That means and will return true for us in this case. But had it been, we have 5 greater than 3, which is true, and then 10 greater than 20, which is false, and will return for us false, right? Then the second one is or. Or returns, or is like the more receptive one. Like you can just look at and as a very strict boss that requires you to have everything 100% true. You have to, or a very strict lecturer that expects you to get everything 100% before you pass the course. But or is like the more receptive one that says if you get at least one answer correct, you have passed this exam, right? But the and says you must get all the answers correct, or says you must get at least one. So even if everything is false, at least one of them has to be true then for all to return true, right? So in this case now we have that 5 is less than 3. We should return what for us? Can someone try? 5 less than 3 should return what for us? Is it true or false?
False.
False.
False. Thank you.
False.
Thank you.
Yeah.
Then 10 greater than 2 should return
True.
True.
true. So that results in true because at least one of them has met the requirement. That means if not for this, everything would have been false. But this 10 greater than 2 came to save the day, right? So that is it about that. Then not is used to reverse the result, right? So if I say not true is false. Not false is what? True, right? So in this case, now I have 5 greater than 3 should have given us what? True or false?
Shall I give us true?
Thank you.
But the not operator makes it
Yes, but the
false.
not operator has made it false, right? So let's see it here and play. So if I put this, it tells me false. Now if I do not, what will it give me? What will not give me? Can anyone try? Hello?
Sorry, I think I lost you at some point.
Can I try?
Yes, you can try.
Can I try?
Yes.
Not will simply give us true
Why?
because if not gave us false and not again is coming to give us the opposing value of what the earlier not gave us, then simply is going to be true.
All right, thank you. Now let's try it. Let's just play around with something funny. Print. Maybe. Let's remove the first note. Right. Let's do another crazy thing. Let's say not. What would that one give us?
False. Sorry. Okay, I don't know. Can I try?
Yes, you can try. You can
Hello,
try.
can I try?
Yes, you can.
So I believe the first one would give us false as seen in example 3. The next will give us true, then the third will give us false again.
Okay.
So that's false, true, false.
Okay. Any contrary opinion? Is anyone challenging that? 1, 2, 3, 4. I think this is going to give us some error. Okay. Correct. So the first time we have not. The evaluation starts from the what is innermost, the main value here, which is 5 greater than 3, which should have given us true. Now we noted this, and then that true became false, right? So that was why we have it here. We have it as false here. Now in the second case, we have what we got initially was false, right? This one, this second one simply inverted what we got in this first one. Maybe once I stop hearing background noise, I start fearing that I've gone offline, but it seems like everything is still fine. So it came and noted the false that we got in this first line, so that false became true, right? Now in the third case, the true that was noted, that was gotten here, was noted again, inverted again to false, right? So an easy way to look at this is we have even number of in this case whereby we have even number of knots, right? The two knots cancel each other, right? But when we have odd numbers, as we have in this first one and in the third one, the final answer is going to be one knot is going to remain, right? So even if I put up to 5 knots here, it will still give me false, right? But even if I put 20 knots here, which is even, it will still give me this one, which is true. So that's it about that. Don't worry if it's not making complete sense yet, just hold on, right? You still get to will still get to make sense eventually. But that is it about logical operators, and logical operators are actually very, very important as well. In fact, everything we are discussing so far are very important, because these are the building blocks for your logic, and you know that coding is all about logic, right? Being able to break down complex and then create different scenarios and assign them what would happen if this is the case. If a student registered for a particular examination and they did not see their results, right, the support tickets they would open might be different from a student who did not register, right? So you can create different conditions based on the ability to apply these logics, and logical operators help you to bring a complex set of statements, expression together to make sense of, right? Now let's look at additional examples. We have length is 2, we have width is 4, then the third variable here is height is 10, right? So let me see that. Let's talk about not and combining them. Okay. Now, all right. Thank you for that, Richard. What he's saying is that I should talk about. Remember when you go up here, right? When you go up here, we cover the comparison operators. We had this one, which is this exclamation mark, then equality, right? Now you remember that here we still call this one not equal to, right? Now we're talking about another not here. Like what made this thing not equal to is just because of the presence of this, right? Now there's a second case whereby we now have another not which we type as not, right? Not, right? Now how do you know when to use which one to use and at any particular point in time? I think the first place to start is by knowing where each one of them belongs. The one you type as not spelled is a logical operator, so it belongs to a different category of operators, right? And what are logical operators used for? They are used for combining multiple conditional expressions, right? For combining. But this second one, or rather the first one here, which is this one, right? Which is a exclamation mark and then equal to, is a comparison operator, right? So this one is used to compare value, not to combine. It is used to compare different values, the one to the left, the one to the right, the operator and the operand, not combining, right? So now let's look at an example where the two of them can come together. Let's see what we will get, right? So let's say I have this. Okay, let's use our example of length and width that we have here. I've already expressed length and width and height and assigned them values. Now let's start with the first one, which is this. Where is that sign? Which is this, not equal to, right? You typically want to use this when you want to compare two values, not combine, right? Or rather, when you have you typically use this one when you have maybe some numerical operations you want to perform on them. So let's say I want to now say something like a length is not equal to width. What should this give me? True or false?
True.
True. All right. True. Now, if I want to negate this, right, I can use the second not which I type out is simply to negate whatever value. It's just like a spoiler, right? It's just like a spoiler, right? So if I type not, what do you think will be the answer now?
False.
Correct. So I hope you can see where they come together. Now, you might be tempted to make a mistake like this. Maybe let me create another cell. You might be tempted to make a mistake like this. Maybe you now type something like this. Length, not width. Length, not width. Let's run this. You will run into an error, which tells you syntax error. You don't write this in Python, right? Because this one is expressed. This is like a function. Remember, all the time. Maybe okay. No, not necessarily because it's like a function. This like it doesn't work that way because this operator does not operate on maybe comparing values with values, two values, right? It's not a comparison operator, right? It's a logical operator, right? It only comes to change whatever. It only comes to change whatever you have gotten the final evaluation to the opposite, right? So you can see how the two of them can work together, right? I hope that adds additional clarity to the two of them, like the differences, their differences, and when you can use each one of them, right? Did that help? Hello?
Yeah. That's cool.
Okay.
Yeah.
Now let's look at another category of operators, right? No. I think we've covered them. We've covered them. Sorry, please forgive the background noise and let's proceed. If you can hear it, kids must be kids. So the other thing we'll look at, yeah, we've covered the operators basically, but we're going to do maybe play some game. Okay, I forgot what I did there. Okay, now this is more like understanding it more extensive. Like this part pieces everything, most of a number of the things we've done together, and then to add to paint clearer picture of that. So in this case now we have this plus and operator, right? So we have this length is equal to 2 and height is equal to 10, right? Now we have defined length, assigned the value of length to 2, and then assign the value of height to 10. So automatically this should return true for us. Yeah. Now what happened here is that it first checks the value of length, and it happened that the value of length is true. So that gives us true. Then it checks the height, happens that the height is also 10. That gives us true. Then since the two of them are true, remember the condition for true, for and, right? The main focus here is and. Since the two of them are true, then the result is true, right? Now, the OR operator, right? In this case, length is equal to 10 or height is equal to 10. What happened here was that, what do you think would be the answer in this case? Oh God, I've exposed the answer. Well, still the fun. If you didn't see the answer, what do you think would be the answer? Going up.
So can you come again with the question?
Okay, the question is, we want to see how, or based on what we've learned about all operators, the all operator, right? Now the expression here says length is equal to 10 or height is equal to 10. What do you think the result, the answer will be? We already told us that the value for length is 2, the value for width is 4, the value for height is 10. Now this expression is now checking to see something. It says is length equal to 10 or height is equal to 10? What would be the result? Hello? The network has gone bad. Hello? 10. Hello? 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 Can you hear me now?
Yeah, you're audible now.
All right.
Yeah, yeah. The,
All right. I think my network cut me off. So,
You need to share your screen again.
oh, sorry. Thank you.
sorry, I was going to say if I could also try. If you don't mind.
Okay. All right. No problem. All right. You can try. So, what would this expression? Sorry. What would this expression result?
Okay, so I second the answer of the earlier guy. It will still be true because it's the or operator, the or comparison operator that requires the operation to meet at least one of the conditions, which in this case, its height being 10, even though the length is not 10. So it's true.
All right. Thank you. That was correct. So, what happened there was I checked for length and discovered that length is actually 2, not 10. So, the answer for that was false. But that was not the end of the evaluation. It came again and then checked for height, and it happened that height was 10, which is true. Right? So since at least one condition is true, the result is true. Now let's see how you can combine the two. I mean, combining two logical operators and not. Now, in this case, length is equal to 2 and not height is equal to 10. What would be the answer?
So can you come again on the question?
Okay, length equal to 2 and not height is equal to 10.
I think it will be considering only the length equals to 2. If it's true, then it gives us the true answer. If it's false, it gives us the false answer. I'm not looking at the height equals to 2.
Okay, in this
Like
case,
it ignores the height equals to
now tell me why you should ignore the
Can I
height.
try?
Yes, you can try.
Okay, but is he done answering? I want to come up when he's done.
Okay, so what is your answer? Was it Eben that spoke last? I did not take notes.
Okay, okay. Okay, so the answer will. Can you hear me?
Yes, I wanted to know who's speaking. Yeah.
Can you hear me?
Yes, yes.
Since Ibrahim, the answer will be false because ideally it should have been true, being that the length is 2 and the height is 10, but the not logical operator which negates or reverses the result got in this case, the value of height being 10, will now make height not equal to 10. And you know, the AND operator requires that the operation must meet the two conditions. In this case, not just length being 2, but height also being 2. So because length is 2, but height is not 10, because of the not operator which reverses the value of 10, is why it will be false, because the two conditions do not meet the requirement for the AND um, logical operator. So again, the answer is false.
All right, thank you for that. Any contrary opinion? Anyone contesting this? He said the answer is false. Any contrary opinion? Now let me just maybe do something. Let me just copy this again in case we've forgotten what the actual values are. Let me just bring this down here. May God, I exposed it. If you saw that, then that was your luck. So this is what the actual values were before the expression. And the expression says, what will be the result of this expression? Length is equal to 2 and not height is equal to 10. Is there any other person that can try?
So I think going by that, I think the answer is still false
All right.
because the length it means this condition, but it negates the true which is supposed to be true, but because of the not, it negates it. So because the two conditions are not met, so it's going to be false.
All right. That was correct. Both of you were right. The answer is false. Now, how can I make this answer? How can I turn this answer to be true? At least I can think of two different ways I can make this, turn this to be true. Can anyone help modify this to give us true?
So one way is by removing the not.
Okay. By removing the nots.
Can I try?
Yes.
Okay, so like you rightly said, there are two ways. The first is what the previous person said, which is by removing the knot. Then the other is by adding the knot to the first operation, which is length being equal to 2, because that way length um, will truly no longer be equal to 2. The same way height will no longer be equal to 10 because of the not logical operator. So
Okay, so you suggest that this will give us, okay, let's say you suggest that this will give us true, right? And you also suggest that this will
exactly.
give us true, right? Any other person will try that wants to try? Anyone else?
So
Okay.
if you change the value of height,
Sorry?
if you change the value of
If I change the value of length,
height,
height to what?
let's say 4,
4. Okay. Okay. You are assuming this will give us true. Any other person? Sorry. Who spoke last? Who spoke last?
I did.
Who owns this one? The second person that spoke. Hello?
Yeah, I'm there.
Your name, please.
Hello.
Yes, your name.
No, Eben. Eben.
You spoke first, right? Was you that?
I spoke second.
Oh,
Second.
okay. Sorry, who spoke?
Though I was seconding the answer of the first person while giving my answer.
Okay. Well. No need for that. No need for that. All right. Now let's. Do you know that all of you tried, but there would have been a shorter, a simpler method, though not all of them are correct actually. Now, what if I come and not everything in parentheses? Don't you think that would be the easiest way to do that? What do you think? This one. Now let's evaluate them critically. This first one says, if I remove the not here, right? So it now comes and says height is equal to 10 and length is equal to 2. Yes, height is 10, length is 2. So it should give us true. So this is correct. Right, this is correct. The first, this one. Now this one now says if I not length, like if I not this one that says length is equal to 2. Now let's see what will happen here. Length is equal to 2 give me true, because length is equal to 2. If I not it, it will give me false. That means everything here is replaced with false. Everything here is replaced with false. Right? Then it comes here again and says height, it evaluates this one, height is equal to 10, which is true here, right? But it's not the true that changes, and then that changes this one to what? False. So finally, false and false will give us what? It will not give us true. The AND condition states that the two of them must be true, right? So you can see that this is not correct, right? This is not correct because false and false cannot give us true.
So can I ask a question?
Yes.
Okay, so just to clarify, can I write on?
Yes.
Okay, so it's just to clarify. I was thinking that when you say with use of the not operator, okay, no problem. I think it's clear now.
Okay. See what?
Yeah. The emphasis is on the true condition being met.
Okay. Yeah. Let's watch out. False and false. And false gives us false. The condition for truth, for AND to become true, is that the two conditions must be true, right? That's the requirement for AND to give us true. So this is going to give us, this is not going to give us true, right? This is going to give us false. Then this is going to give us true, right? Then this one says not this one. What really did we do here? Okay, this one says change the value of height to something so that it gives us false. Now it says length is equal to 2. Correct, length is 2. Now it now comes here and says height is equal to 4, which is false because height is actually 10. Then we've gotten false here. It now came and noted the false, right, to change it to true. So that means we now have true here, and then we have true here, and then everything now gives us true. So this is also correct, right? Now finally, this here is the same as the first expression that gave us false, only that false was eventually reconverted to by using this not. That now forced it to become true, right? So this is going to give us true. Now let's run them. So you can see that this first one
Sorry,
false.
do you mind going through the last statement again? I didn't really get it.
Okay. The last statement said, this was my own suggestion. The question was, how can we make this first statement that gave us false? What are different things we can do to change it to true, right? So now I mentioned that another way we could, after all the suggestions, which a number of them were correct, and I also suggested that since the final result we got for this one is false, right? If we not everything, like if you watch here carefully, before this print statement, I mean, the print statement, if I remove this print statement, right? Oh, sorry. If I remove this print statement, you will see that it's just like everything here, there is length is equal to 2 and not height is equal to 10. You can see that this is exactly what we have here. Length is equal to 2 and not height is equal to 10, right? Just for that sake of that print statement, right? Now, I now came and noted it. Remember that this one already gave us false, right? Which was the first thing we tested. It already gave us false. Then I now came and inverted the false, the final answer it gave us by adding this not, right? And placing every other thing in parentheses. So that changes the not, the false that we got initially with this one to true, right? So if you now check now, this one is the original one, which it gave us false, which is this one. Then this second case gave us true, which is correct, as we predicted. This one now gave us false. We predicted it to be false, yeah. Then this gave us true, and we predicted it to be true. Then finally this gave us true, which we predicted to be true. So for this,
So you can ask the question.
yes.
Okay, when you're done, I'll ask the question.
Okay, all right. So I think we're actually done with this example, this very one. Now let's look at maybe let's just put maybe just summary of the answers. The first one gave us true, the second one gave us true, the third one gave us false. Yeah, so you can ask your question before we proceed. So we're like 13 minutes to the end.
Okay, so if I'm getting you right, indirectly you're trying to say that for the the true condition to be met, the two conditions must be true, but for the false condition to be met, just one of the conditions must be false. More like true plus true, false plus false, but false plus true is still false. Is that what we're trying to say?
Okay, now see where you are mixing it up. True and false are not conditions. The conditions are the operators, like and.
Okay.
Do you get it? So you instead say for the and condition to be met, right? For the and condition to be met, all the expressions must be true.
True.
Right?
Okay.
Then for the or condition to be met, at least one of the expressions must be true. That is for the for the or condition to give you a result that is true. Do you understand?
Sure.
Then at least one of the expressions or one of the conditions inside there must be true. At least one. Do you understand? So that false and false will give us false. True and true will give us true. True and false will give us false, because one is already false there. Do you understand the logic?
Okay.
Then
yes.
False and false or true will give us what?
False.
No.
Okay, so false or true?
Yes. See it here. It's a bit tricky. It's a bit tricky. Let's see it. True and true equal to true.
That's true. Yeah.
No. True and false is what?
False.
False.
It's false.
False.
Alright. Then true or
Awesome.
true or true will give us what? True.
True.
True. Yeah.
Right? Because the or condition requires that at least one of them is true. In this case, the two of them are true. Now let's see. True.
Yeah.
Let's say or. Okay, let's say false or false. What will false or false give us?
It's false.
False. It can't be true.
Yeah, that's true.
It can't be true. Is that clear now?
Yeah, I'm following you.
Okay.
No, it's tricky.
Yes, it's tricky. It takes practice to you'll get used to it with time. Now let's see. Now I keep mentioning it takes practice. takes practice, and this is a critical time whereby some people can decide that this thing is not for me, because your head will be doing you somehow. But I bet you that once you can get this right, once you can get, maybe you cross this phase, right, you will definitely enjoy. Okay, you definitely enjoy the experience. I just want to convert this one to code. Let's verify what we just did. Let's verify what we did. True and true. Oh, sorry, I used the wrong list, and I just wanted to. Remember that it's case sensitive, just because I put them in capital. So I would have said print, because if I don't put the print here, I want to print out all of them. So let me just put the print here. Print everything.
Sorry, can I ask a question at this point?
Yes, you can.
Sorry, I'm returning you back.
Oh.
Okay, so you know for the all. Okay, so you know for the all condition, is just sorry, I meant to say, you know, for the all comparison. What am I saying? You know, for the all logical operators
Yes.
too, because and or not logical operators.
Yes.
Is just one of the conditions that needs to
be true.
be met.
Yes.
So,
Yes.
okay, that needs to be true.
Yes.
Okay. I see the confusion. I was thinking it's just one of them that needs to be met. I was like, whether it's okay, I get it now.
Okay.
Yeah, just one that needs to be true. So
Okay.
with respect to the true. Okay, thank you.
So I advise that if you want to really reduce, maybe if you want this not to confuse you, right, pick one as a basis, as the fundamental. Like, assume that what you are looking for is true. Like, hold on to true, right? You're looking for conditions that meet the requirement for true. Don't be looking at it from both ways, maybe false and all those things. You understand? So that you can just say, okay, in this case now, what would make an expression that has the AND operator to return true, right? And then the answer is that everything in that expression must be true, right? Then I can answer what will make an expression that has the OR operator to be true. Then I would simply know that one of them must be true, right? So once I have known that, then I know that when I have true and true will give me true, but true and false will give me false, because the false has spoiled the requirement that and needs. But true or true will give me true, and true or false will still give me true, because OR is only looking for one condition to be met, one of the requirements, right? I hope that adds more picture to this. Don't worry, with time, when we start maybe applying them to real world case scenarios, you will definitely understand. Yeah, it will take a bit of practice. That is why the exercises are supposed to be taken seriously. So this is just like us doing the exercises together, but if time permits, I will be able to come up with another exercise that we can practice this ahead of the next class, right? So this is just about explaining everything. No need for this again. So this is already 9:25, but we have to cover the last one, which is the identity operators, and these are used mostly in search, right? There are just two of them, is and is not, right? And let me just give an example. Maybe my maybe list of numbers greater than 0. Okay, let me just say something like what example? List of teleconferencing applications teleconferencing applications equal to, we have Zoom, we have Zoom, we have Google Meet, we have our favorite GC, which is what is powering this call. We have what else? Microsoft Teams. We have, there are a lot of them. We even have okay, maybe let's say these are the ones we can remember for now. Then we still have a who can remember another one? Even WhatsApp this thing still does that, but let's assume we just limit the list to these top 4, right? Now what I want to do with search is maybe I want to know whether there's one that I'm missing out. Let's try something out. Let's say WhatsApp is in this. Okay, this is another this syntax. Okay, this may not be the perfect example to illustrate this. How can I do this? No, this may not be the perfect example to illustrate this. Okay, let me say something like the English alphabets, right? Let me say the English alphabets, for example. Let me say alphabet or my name. Okay, my name equal to Kenneth, right? Now I want to perform a search to know whether the letter A is in my name. Let's see. A is in my name. I'm just giving my, okay, I put is in.
Sorry, can I say something?
Yes. This gives me an. I'm making a mistake. Come on, bring the question forward. Let me see if I can fix this as we are looking at that. Hello?
Okay. No, I was just going to add to your list of telecom apps that there's also Skype, there's Slack.
Okay, we have Skype and Slack. Okay, thank you. Okay, so I think in the process I was able to figure out a typical example I can use to illustrate this.
How about if is then your A in quotation in my name? I don't know if that's work.
Okay, so so what will happen? Let me just get one of these, which is this one. Just give me some time to Z in print. Yes. Okay, see what I just did now? Is, like I mentioned, is used to perform search mostly, right? So in this case, I have this list of teleconferencing applications, right? Then you zoom in list. Let me see this work. Yeah, thank you. So I think we fixed that. So I have this list of teleconferencing applications, and I have Zoom, Google Meet, GC, Microsoft Teams, right? So I now told it if Zoom in this list. Okay, but in this case, the example wanted to illustrate is, right? So I think
Exactly.
that was tricky. Okay, let me see. Okay, now let's see something. If what I'm going to do this time around is I want to select this first one. I want to know what is in this place. We've not done data structure. Pardon me for that. In case you don't understand this example I'm going to do now, this illustration. We've not done indexing, right? Right?
Yes.
Let me see something. I can't think of a perfect example to illustrate here. Okay. Richard, do you have any? Are you still there, Richard? Can you help out? If you have.
Yeah, can you try this? If like where you are, so can you try this if that's going to make sense? Yeah. So if list of telco app like the is
Okay.
Zoom 20 years. Check that and let's see something. No, the cell that you are in.
Okay, here is.
No, this is Zoom 20 years. And let's see if that makes sense.
Okay. Okay. That did not. Okay. 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 I did not put. Yeah, that worked. Thank you. So my head was just blank, but that worked. So what we did, although it's giving us
Yeah, it should
yeah, this is
actually
not.
be an assignment.
Yes, this is just like a makeup example because we don't have anyone handy to give now. But typically, no, the safer way should have been this.
Sorry.
So that's why it worked. It worked, but you would not typically do this. It's telling us syntax warning is with string literal. Did you mean double equal? It's telling us that the most appropriate way would have been this. Yeah, but it worked. Just like running on 3 wheels because you. Yes, come on, go on.
Don't do, I just want to suggest like the earlier guy who suggested. Okay, how about if we try if Zoom is where we use for the is the double equal to sign. So if Zoom is then list of telecom apps index. In other words, if Zoom is the actual telecom app index 0 of this list of telecom apps, then print yes. I don't know. Because logically
Can you come again?
So if Zoom, so instead of Zoom being at the, because you know for the last one you did, you got a yes, just that it had warning messages. So I'm just like,
Yes.
how about we try if Zoom is then list yes, then list of telecom apps index. In other words,
Like
if the telecom app Zoom is actually what is in index 0, which is the very first one, then print yes.
okay, that means
If Zoom is list of telecom apps index 0.
okay, the first one. Okay. I think
I don't know
that's
if you get
similar to like this, right?
index 0. Exactly.
That's the same.
Yes.
The same. That's the same thing we did here. Only that this one.
This
Oh, I didn't know.
Yeah.
Let's
Try that and let's see. Try that also.
let's see. Let's see. Just having fun. Yeah, the same thing. The same thing.
Yeah, okay.
But one way. Oh God, how can't I have example? A typical example of is to use here.
Sorry, I want to ask, can't we start the statement with it? Must it be if? So that maybe it can be something like is Zoom in quotation in list of the apps. I don't know if that works.
This is Zoom.
Yeah, that even sounds more logical. Sounds more logical.
Is Zoom what?
In
Okay, in. Okay. Okay. Is Zoom in.
Even for the in, I think if we use the assignment operator, it should still flow. Because like saying is Zoom the actual app in index 0.
Yes, that one would work. I think that one, okay, let's see. This one might, yeah, it might not work. I've not seen where they start a statement with is, right? So that's, I think that was the first fear. So is Zoom in list of telecom apps? No. How we would have structured that is
If
yeah, if Zoom in, it's not is that will
yeah,
come in. If Zoom in list of telecom apps. Or if you don't
because the
want to
point
make
of
it
error now is the
or
is
you don't
keyword.
want to, you can just even remove this one and say Zoom in this, it will return true for you because Zoom is in it. It already assumes that you are trying to perform a setting in, right? Zoom in telecom list of telecom app. So I think we may not have to dwell so much on this, but someone's hand is up. Richard, okay. You can unmute yourself and talk.
Oh, okay, yeah. So to contribute to that, I think is mostly used to compare the data types in memory, like what is the computer um what's the object, the object in memory, so not the data type. So uh, if you assign a value to, let's say, please, can you guys hear me still?
Yes, yes.
So if you should assign a value to, let's say, x, and another the same value to y, inside the memory of the computer, it sees x as the values of x as a different object and the value of y as a different object. So that is what is used to confirm. So I
Okay.
think I sent an example in the chat, so you can try that
Okay.
one out. Yeah.
Okay, let's see.
So that's something I can contribute to.
Something like this, right? Yes, correct. Okay, yes, that's the D. This is what you meant, right? X
Yeah,
is
yeah,
Y.
yeah,
All right, all right.
yeah.
Thank you very much. Thank you for coming to save the day. Then this should give us false. Okay, so I think this is not what you would
Eh,
use in many cases, right?
Hello.
Yes, we can hear you.
Okay, I just dropped um, an example case that we can use that I feel should work
Okay, if list of because
for what we're trying to sort out. The use of
yeah, but this is if, not is now. Remember, we are looking at if is where to use is, not if. Yeah, I think he has Richard just provided an
okay.
example. That where you use this typically is for maybe when you want to compare objects stored in memory, right? Just like we would have done maybe x, y, right? So these two should work alike, right? Print.
Yeah,
Yes,
it's
to give
true.
us
He's right. He's right. Use
so
for object identity is
yeah. So the two of them should work exactly as planned. So I think that's a that gives us, then of course once you've known what is and then of course is not, so it's just the opposite. So x is not y. What do that? It should give us false because x is y, right? So I think that clarifies everything here. That clarifies it for us, right? In many real world maybe applications, except maybe you are trying to, maybe you are debugging your code or doing a number of other things, or yeah, you can still use this in many cases, right? But you could see that this double equal to sign is going to be more commonly used. You find it in more common use than the is that we're using. We're trying now. I hope you can still hear me and see my screen. Right now, we
yeah.
are
Sorry, can I
already 10
ask
minutes.
something?
Yes.
Okay, so are you trying to say that with respect to Python, if it's used for like value equality, while is for object identity, like what you're trying to do now?
If, no, we're not talking about if here. If is used for conditionals. We've not even covered conditionals. Do you understand? I'm talking about you could see that before I close that out, you see that this double equality, right? This double equal to still works the same way as is, right? X
Yeah.
is y, give me true, and then x is equal to y, still give me true. So maybe it might require maybe checking the explicit need for is. Since this double equality can still do the same thing for maybe that will call for further investigation or research, right? And the last thing we'll look at is just maybe to see their operator precedence, right? This is actually a very bogus topic, like, because you also have to consider the different types of operators we've covered so far and how they come in and all that. So I did not do justice to this one. We just have an example whereby you have addition, multiplication, and then exponentiation, right? So in this case, what happened here is I don't know whether Bodmer's did everything for us, but we could see that it started here. 2 to the power of 2 gave us 4. That means this to the power is of higher precedence. This exponential is of higher precedence than multiplication, right? Than multiplication. So that means 2 to the power of 2 gave us 4. Then that 4 multiplied by 4 gave us 16. Then 16 plus 3. Of course, you already know that plus and minus are lower precedence than addition and multiplication and division. And of course, multiplication and division now are now of lower this than exponential, right? So that was why we got 19 here. But there are other, maybe in the exercise we are going to look at other ways to maybe to break up such expressions so that it will be clearer, and a number of other things we can play around. So what we have now is data structures, and of course it's not the topic for today. We've exhausted what we wanted to cover today, and I'm glad we were able to cover to a reasonable extent. So thank you for staying put up to this point, and maybe we can spend the next 5, or if anyone has a question or whatever you want to chip in, this is now the time.
Yeah, hello.
Yes.
Okay, so I just want to make a little contribution to the last part you talked. I don't know if I can go ahead.
All right, go on.
Okay, so for the Bodmas or
PEMDAS.
PEMDAS part, because I know we are more familiar with Bodmas, but for the PEMDAS, the P means parenthesis, E means exponent, then
Exponents.
the others are the ones. Yes, so
Multiplication.
it's now more
Okay.
division, addition. So it's now more like the kind of question determines which to use. For example, now in
Okay,
this
in this
question,
case, yes.
there was not like brackets yet, so
Yes, so
that's
it's
why we
PEMDAS.
didn't use. Yes, so that
Okay.
one will be thinking it's guesswork you are doing. Yes, there is a
Yes. Yes.
pattern to choosing whether to use board mass or PEMDAS.
Oh. Thank you very much. I think I
So
just
it's
learned
because there
this
was
one.
no brackets.
Yeah.
Yeah.
I think I just learned this one today. Thank you very much. It's a two-way thing. Thank you
Yeah.
very much for that. All right. Any other person that has anything to chip in? Anyone? Okay, maybe in the next 10 seconds, we'll end the call if nobody's.
Sorry, I want to ask. Then, how do we? Can you hear me?
Yes.
The board mass and the pengas. I'm just hearing this for the first time, though. So, how do we know that it follows this or this? How do we know? Because I think the difference here is the exponential, because the
Yes.
parentheses and the bracket are equally the same.
Okay. Yes. From what Eben just chipped in, PEMDAS. Use PEMDAS when, for example, you have things like exponent. Remember that this sign tells us exponential, like I illustrated during the arithmetical operators, right? We have exponential of something, right? So in this case, we don't
Yeah.
have brackets. Board mass means brackets of there is division, multiplication, addition, and subtraction. Every other thing from here, multiplication, division, addition, and subtraction are the same because
Yeah.
like m is for multiplication and d is for division, which have the same um, precedence. They have the same rank. So whether d comes before m or m comes before d doesn't change anything. Just like we have it here, this is dm, then this is md, then this is a and s, just as they appear here, addition and subtraction, right? Now the only thing that changed here is that we don't have b, that is this bracket, right? We don't have brackets. What we have here is um, exponents, right? Right? Um, Eben, confirm. You say P is for what's power or exponent? Which one?
Set
And
parenthesis.
Par okay.
P is for
Parenthesis.
parenthesis. It's just
Okay.
yes. So can I
Okay.
continue?
Yes, you can.
Okay. So what I was going to say is that um, in English usage, at times people can take bracket as
Yes.
the alternative word for parenthesis.
Parenthesis.
So it's
Yes.
now more like if in the question parenthesis or bracket comes first before the exponent, then you attend to the part first having brackets or
Yes.
parentheses before you move to the exponent. But in this case, there was nothing like so like you're trying to follow a sequential order in the use
Yes.
of the operators. So since there was nothing like brackets, so we had to start first with exponents before considering other ones, doing the order of multiplication, division, addition, and subtraction.
All right. So, in my opinion, I think PEMDAS is more comprehensive because it also has the part for parentheses and also has the part for exponents, right? I
I
think
agree
it's
too.
it's
I agree.
more robust than Bodmas. Even though I was shying away from it, even
Sure,
right,
sure.
even back in college, I was kind of I preferred Bodmas, but I think going forward I would prefer PEMDAS because it handles the case of where you have exponents and then we still have parentheses and the rest. So I hope the question was
Very true.
cleared for the person that asked, right?
So, what I was asking, which one now? How do we ascertain that the Python program is using board mass or is using pandas?
Okay, you ascertain that because the
Because
documentation has
there is a
told you.
confusion there. We have MD and we have DM. Like, so which one
Okay, I
does it
think I
follow?
tried to explain that part that MD and DM are the same thing since M stands for multiplication, D stands for addition for division. And I mentioned
If it
initially that
follows this,
the two of them have the
if it
same.
follows this, we have division coming before multiplication,
It
and
doesn't change
here we have
anything.
multiplication.
It doesn't change anything. That is what I say that
It,
M and D have the same. They have the same rank, right? The two of them have the same rank hierarchy. Do you understand? The two of them have the same hierarchy. Just like addition and subtraction, you can choose to subtract. Maybe if you can choose to subtract before you add. It will still not change anything. Had it been, we have enough examples to illustrate here. Let me see. Let me see if we can. Let me see if we can do come up with something. Divide by the 3 exponents 2.
So, sorry, can I attempt to make a contribution to what you said?
Yes.
Okay, so you know in okay, what I was going to say is that so you know in board mass the I'm trying to see how to okay, so I think it's more like this. We know the O in board mass to mean off. I
Mm-hmm.
know off is like saying times or
Yes.
multiplication.
Yes.
So at the end of the day, what he is saying, I mean, what you are saying, that they are the same thing, you are still very right because if off means times, which obviously is what it is, then multiplication is coming before division because times is still same multiplication. That is for board mass. Then in PEMDAS, multiplication to still come before um, division. So you are still right. It's like you are saying the same thing. It's just being um, so in both cases, multiplication still comes um, before division. I don't know if he got what I'm trying to say. Like off
Yes.
means times and times means multiplication. So it's like saying if I take, your focus was which comes before, is it D or M?
Yes.
Now off is like another term for multiplication, which we commonly call times. So it's like saying M comes before D for odd mass. So it's more as if the multiplication is being repeated twice. The first one
Mm-hmm.
in the form of
The
off, and the
and
other
then
one
this
in the
one.
form of M. Yes. Then PEMDAS, multiplication comes before division. So in both cases, simply multiplication comes before division.
Division. Okay, now let's see if we can maybe let's just play around with something. Now in this case, now this expression, now let's see how we can apply BODMAS or PEMDAS. I think in PEMDAS, right, going by P, that is parentheses. Okay, we don't have parentheses here, but let's break this up. Maybe let's use let's apply parentheses to see the order of execution. That means in this case, it's going to be, I think, these two first, right?
Yes, the
That's
exponential.
exponential,
Yes.
right?
Yes.
Then we now have multiplication. That means
Multiplication.
Yes.
like this, right? Right?
Yes.
Then division. Of course, before you do division,
Yes.
um, that means come on, like this as well, right?
Yeah.
Then
Yes.
for this, so we are saying that the answer is going to be 3 to the power of 2 gives us 9. 9 times 8 gives us 72.
Two.
Yeah, 72. Right?
Yes.
4 divided by 72. Let's say 4 divided by 72 gives us a 0.055, right? 3 plus 0.055 gives us
3.05.
3.055. Okay, now let's see
Yes.
if that gives us the answer. Exactly. That
Yeah.
was right. That was right.
Yeah, that was right.
Okay, so, well,
That was right.
this is this is a nice experience. So I don't know. Not everybody did maths in school, but this is just um, kind of basic maths. Maybe basic rule you apply when you have a collection of operators to perform. How do you start? Where do you start? Even our calculators use this method to know how to break complex these expressions, right? So in case you are still confused with this, don't be so much worried. With time it will get clear, and as long as you're with us, you still have enough time to get cleared on that. So just to mention, and any other person that has anything to say before we call it
Yes,
night?
yes.
All right.
Can I write it down?
Yes.
So, while you were talking, I was just doing my research on perplexity, and I just made an important discovery. So, before now, we used to think that off means times for the O in board mass.
Mm-hmm.
But perplexity here is saying that the O actually means orders, which could be powers or
Oh,
roots. It's
oh,
like, in other
oh,
words, exponents. Yes.
oh, really?
So it's kind of like you're saying the same thing because Y
Yes.
bracket means yes, Y
Brackets.
B means
Brackets
bracket
here
in
is for
board mass. P
parentheses.
means parenthesis or still
Oh,
bracket in
okay.
exactly.
Okay. 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 I think this PEMDAS is common among the
So
Americans.
what exponent to
Yes. What exponent is to
yeah,
PEMDAS is a order
yes,
to BODMAS.
board mass.
Okay.
Then board mass is used more in the
In the
UK, India,
UK,
Commonwealth.
yes.
While
Europe,
PEMDAS is used
yes.
in USA,
Yes.
Philippines.
Yes. Yes. Yes.
Then
Okay.
the other thing I also discovered is which is what you also rightly said. Complexity here is saying that for the M and D part, that you don't necessarily always have to do multiplication before division. That
Mm-hmm.
it can go. either way. So you can start with division before multiplication or
Since the two of them
whichever
have
course.
the same, they are the same in
I
hierarchy,
think
right?
so. Yes,
Okay.
even though the acronym lists one before
Okay,
the
now
other.
let's see that in action. Let's see that in action. Let me
Okay.
copy this. Let me copy this. The original. Let me remove the parentheses
Yeah.
and reassign them. So in this case, let's of course others. This one will go first, right? Then let's
Yes.
see if we can
Bracket.
do the division first before the multiplication, right? Like this, right? Right?
Mm-hmm.
Then let's do this one. It's just that after assigning this, it will look like they are all the same. Okay, well, it's fine. I think, yeah, like this. Then finally, we'll now do the last one, the final one. So that means starting with the innermost one, this one will give us 3 to the power of 2, give us 9, right?
9
Then after that, we'll now say 4 divided by 9.
divided by 9
So that means 4 divided by 9
divided by 9
gives us 0.444. Then that's
times 8.
0.444 times 8
That's 3.5.
times 8 give us 3.555. Then
Yeah.
that 3.555 plus, remember we've not done this one,
3.
plus 3.
Yeah. The answer is different.
The answer is different.
Yeah.
The answer is different.
So
That means
I think
it's safer to
I think
multiply
it's safer
first.
to take your route.
Yes,
Yes.
multiply
Yeah, it's
first.
safer.
Multiply first.
It's safer to multiply first.
Yeah.
Yeah, safer.
Okay, it's nice. It's a nice experience for everyone. Okay, I hope everybody benefited from this because I also learned, it helped me clear this about both maths. And then thank you, Ben, for that clarification. And then I don't think I should still ask if anybody has additional question. Please, if you have another question, bring it up either in the DM or in the group so that we can go and rest. It's already almost 10 p.m. here. So
Sorry, mine is not a question, but
okay.
I just need help in the Python 3 that you are using, or the this thing. I opened the Anaconda, but I'm not really getting this interface that you are using. So I don't know if you could just look at it.
Okay, you're not getting something like this, right?
Yes, I'm not.
Okay, well, how does it look like?
Is it possible I share my screen?
Okay, no, what will happen? Maybe you can. So I don't keep every other person.
Maybe just
Yes, maybe it's in itself first. So but actually, before I updated my Anaconda, it was looking a bit different though. So this one, maybe you need to upgrade to the most recent. When did you install that?
I just installed it a few days ago.
And was it the most? Did you collect from someone, or you downloaded it directly and downloaded the
No,
most recent?
I downloaded it and it popped up an option of updating it, so I did the same as well.
That means did you update?
Yes, I did.
Okay, what I'm saying is that this was not the usual Anaconda and usual Jupyter notebook, right? Initially mine was looking kind of, but I think this was an improve. This is like an improvement. There are a lot of things they added here. Sorry, the number of things they added, including their what's it called, even their AI stuff and all that. Right, so I'm also kind of still feeling this experience, which I prefer to the old version. So maybe you can chat me up so that maybe you can look at it again and see the version you currently have and see if that's where the difference is coming from. But most likely it's from the version because I've experienced the old version, which is kind of very much different from this one. So maybe you can chat me up and we can look at it again after this call. So we don't
Yeah.
keep everybody.
Will that be immediately after this call, or maybe later. I don't know.
Probably, can we do it tomorrow because like I'm tired, honestly. I just came
Okay,
out
no
from a
problem,
program
sir.
today, and this class must hold like 3 days since Friday. Not had a good sleep, so I just need to maybe see if I can use this night and recover. Then tomorrow we can do that. You can send me a message tomorrow. Then maybe I can just have a call and then see. Okay, so thank you everyone for your time and contributions. Thank you so much. And on this note, I wish you all a wonderful night's rest. Richard, thank you for the work you are doing in the background. Thank you, Ben, for your contributions. Thank you, Peter. He said KXYZ Walker. Okay. Teresa, Ro, Margaret, everybody, thank you. And have a wonderful night's rest. I'll be ending the call now. Thank you once again.